Hi guys, today we're going to be determining equations, mainly of root graphs and hyperbolas. So the first one here is pretty straightforward because they give us the form that it's going to be in. So usually step one would be to identify the form, but as we can see, they've already given us the form. And in fact, we're only needing to find the value of a. So all you need to do when you have any point, the usual situation is you sub in that point. So 6 is the y value, and that equals a over -2, which is x, plus 8. And then we can just simply rearrange. Whoops. So we get -2 equals a divided by -2. And then, of course, we're multiplying by -2 on both sides. So that means a is going to equal 4. So a good idea is to then write the equation again. In this case, they're only asking us to find the value of a, and we've done that. But often they'll ask us to state the equation. So if we do both, we cover all bases. So y equals 4 over x plus 8. So it's pretty straightforward, just subbing in a point. Over here we have one which is another subbing in situation, and they've given us the form. So once again, we don't have to identify the form of the equation. It's already given to us, and they've given us 2 points. So what we need to do is substitute those 2 points in just like before. So the first point, 4, 2, well, that's going to be 2 equals a x, which is 4, minus h. And, of course, the second point, which is going to be 7, 4, and that means 4 equals a 7 minus h. So now that we've got that, we can, they're simultaneous equations. So I'm going to divide these simultaneous equations. So let's say this is equation 2. And this is equation 1. So actually I'm doing equation 2 divided by equation 1. So that's going to be 4 equals a root 7 minus h divided by 2 equals a root 4 minus h. And then, of course, this is going to eliminate a. And now I'm going to get 2 equals root 7 minus h over root 4 minus h, and we can square both sides. So we'll square this, so we get 7 minus h over 4 minus h equals 4. Multiply both sides by 4 minus h, and then we're going to have 16 minus 4h equals 7 minus h, and now I can just solve. So let's see, I'm going to say -h plus 4h. So we're going to have 3h, and we'll minus 7 equals 9. And I get h equals 3. So that's the value of h. And now, of course, if I want to find the value of a, I can just sub that into one of the equations that we made. So it doesn't matter which one. We've got equation 2 over here, and we've got equation 1 over here. And really, it would be good to do the one that's going to be easier. Neither one looks too difficult. I think I'm going to go with equation 1. So you can choose either of the equations, and you'll still get the same value for your a. So 2 equals a 4 minus 3. And that means 2 equals a times square root of 1. And the square root of 1 is 1, so a equals 2. So now I've found the value of a and h. Let's look what the question's asking us to do. They are asking us for the values of a and h, but once again, so that we cover all bases, I'm going to write the equation out again with the values of a and h within it. So I'll write, therefore, y equals, what does it equal? A x minus h. All right, a x, whoops, and a is 2 minus 3. So that would be our equation. So by doing that, we've listed the values of a and h, we've found the values of the pronumerals, And we've also stated them in the equation form. So if the question's asking you for the equation, it means you will get 4 marks. You won't lose a mark for forgetting to do that. Let's move along. And now let's look at some graphs, pictures of the graphs, and see how we can determine those equations. So let's move this one down a bit. And maybe this one across a bit. Okay. So let's start with this one here. So we want to find the equation of this graph here. So step 1, we're given a picture there and we've got to identify the form. So whether you're given the picture of the graph or a sentence describing that it's a hyperbola, a truncus, a root graph, whatever it might be, you want to determine the form or identify the form. And in this case, we can see it's a square root graph. So this is going to be y equals a root x minus h plus k. So in your book, they use h and k for quadratic, hyperbola, truncus, everything. They use h and k. You don't have to use h and k. You can use b and c if you like. It doesn't matter what the variables are. And in fact, in the next one, I'll use different variables because it really doesn't matter what variables you use as long as you know what you're doing with those variables. The next step, like when we do quadratics, determining a rule, we put in the obvious information. And the obvious information, if you had a parabola and it was in turning point form, the turning point would be the obvious information. For a root graph, the obvious information is your starting point. And what we might do, we might colour code that in blue, so we know that that's what we're using. And then maybe the form, we can colour code in yellow. So now we're going to have y equals a root x. Now the x value, we always go in the opposite direction. So this is a +1, so we're going to say -1 for our horizontal shift. And the vertical value will be the same. So in our case, it says -2. So we're going to write -2. So the only thing left for us to do is to solve for the value of a. And this is the part in step 3 where we say sub in a point to find a, to find that dilation. And we did this with quadratics. So it's just exactly the same, only that the form is different. It's a root graph rather than a quadratic. So now we can say, well, our point is 2, 1. So y is 1. 2 is x. And now we'll be able to solve for a. 1 equals a root 1 minus 2. So I'm going to add 2 both sides. So we get 3 equals 1a, because square root of 1 is 1, 1a or +1a there, whatever, and then we'll just a by itself. So we'll just, a is 3. So our final step is to actually answer the question, which is always the final step. And although I didn't cut out what the question said, this is asking us to find the equation of that root graph. So if we're finding an equation of the root graph, well, we need to actually put the a value into the equation too. So make sure you finish your working out by saying y equals 3 root x minus 1 minus 2. And that will be your final answer. So we solved for a, we've got h and k in there. Make sure we actually put it all together for the final answer. The last one we'll do is this one over here. And in this case, so again, we're going to find the equation. What we need to do is identify the form. So step 1, oops, where we identify the form, well, if we think about the different forms we know, we have, well, root graph, which we just did. We have the root graph. We have, I might draw them. So we have like this. We have parabola. we have truncus, we have circles or semicircles, which we may not have learnt quite yet, and then of course we have hyperbola. So the one we see here is a hyperbola, so we're going to have to put it in the form of a hyperbola. So let's see, it's going to be y equals a over x, and I'm going to say plus b and plus c. In your book, it'll have h and k, and negative h and k. The negative is accounting for that we go in the opposite direction, but it doesn't matter if you call it b and c or f and g, whatever you like, as long as you know what those values are representing. And as we know, the asymptotes, which are here and here, those asymptotes are what's going to give us our b and c values in this case. So the x asymptote, x equals 2, so that means we're saying b is going to be negative 2. So step 2, put in the obvious information, and it's the asymptotes. So we've got y equals a over x minus 2, and so that's the x asymptote, always the opposite direction. So this is a positive 2 there, so it means we say negative 2 in our equation. And then the y asymptote, well, that is at positive 2, and when we do the vertical shift, it goes the same direction, so that's going to be plus 2. So be careful which way you go, positive or negative there. Okay, so our final stage is just to solve for the value of a, and something that will help you remember to solve for a is you'll get some other point, some random point there. It might be an x-intercept, it might be a y-intercept, it might be just a random point. And that point, if you don't use it, then why is it there? So generally speaking, when there's a point given to you, you need to use it. Any information you're given, that you need to use. So that's used to find a. Our dilation. So 3, 3. So step 3, sub in a point to find a. And just to be clear, we can also have dilation factor next to the x, either in root graph, hyperbola, or truncus. You can have that, but for the sake of our questions, we're just dealing with one dilation and just the a value there. So generally, they'll help you with the form, and they'll let you know if there's going to be a second, dilation to consider there. So let's see, 3, 3 was a point. And so we're going to say 3 equals a over 3 minus 2 plus 2. So 3 equals a over 1 plus 2 minus 2 on both sides. So 1 equals a over 1. And we get, well, a equals 1. So in this case, if you had forgotten to do the dilation, you may well have got it right. You may well have fluked it. Because in step 4, where you actually answer the question, well, your value of a, or y equals 1 over x minus 2 plus 2, that 1, a lot of people would just put instead of the a up in the identifying the form stage. But of course, it's not always going to be 1. And as we saw in the previous one, our a value was 3. So you want to make sure that you actually do consider a, and a way of making sure you don't forget is to make sure that you use all the information that's given to you in the question. We've used the asymptotes, and then the shape, and then if we hadn't used that 0.33, we'd know something is missing. So that is how to find equations of truncus and hyperbola, or no, not truncus, root graph and hyperbolas. You also can do the same method for truncus.